Today's video is going to discuss chapter 3.3, rate of change and slope. We're going to break 3.3 into 2 days, so this is going to go over the first half of chapter 3.3. So let's start by talking about what rate of change is. Rate of change is basically a fraction, and it's the change in y on top over the change of x on the bottom. Remember that because it's a fraction, you could divide the change of x into the change of y and you could get a number. So for example, you might get a rate of change that's 5. You also might get a rate of change that's 3/4. Okay? You also theoretically could get a negative rate of change if one of these two numbers is negative. So remember that it's just, essentially it's just going to be a fraction. All right, let's start by taking a look at an example. So this is an example of a table, and you see that this has a rate of, the x is our number of computer games, 2, 4, and 6, and then this is the total cost, and this is what our y is going to be in $78, $156, and $234. And we want to figure out what is the rate of change. So what we need to do is determine the change of y. Now remember, y is listed second, typically in these tables, over the change of x. And so there are a couple of different ways that we could do it. The most logical, I guess the easiest way would be to take this number first, which is 156, and I'm going to subtract 78. So 156 minus 78 would give me a rate of change there. And since I use this number first, I would then need to use this x first, subtract this y. You don't have to do that. You could use these two. You could use these two. Right? You can use any two you want, but if I'm going to use 234 and 78, so I go 234 minus 78, I would then have to have 6 minus 2 as my denominator. But if I'm going to use 156 minus 78 and then 4 minus 2, it's going to look like this. So this is my change in y divided by my change in x. And as I do that, 156 minus 78 will give me 78, and that is then 4 minus 2 obviously will give me 2. Now I'm not done. I now have 78 over 2. The question is, what is the rate of change? If I take 78 and divide by 2, my answer is 39. Now, here's my question. I'm going to come back to this table. What does 39 represent in this particular problem? Assuming for a second this is a real life problem, what is 39? So the idea is that 39 is the rate of change of y as it relates to x. In other words, it's how much change I have in total cost divided by the change in the number of video games or computer games. And so theoretically 39 is the cost of one computer game. So each computer game costs $39. That's why if I buy 2, it costs this much, 4 would cost this much, 6 would cost this much, and we could keep going if we wanted. You also should be able to figure out what 3, 5, and 7 would be using that. All right, now let's talk about a problem in the book. I'm going to show you a table, which I know that when I do this, it's not the most clear. I want you to look up here at this corner talking about the roller coaster. And I want you in particular to take a look at years 2000 and 2002, because we're going to find the rate of change between 2000 and 2002, which is this first line. So you can see that 2000 was 317. This is attendance in millions, and this is years. So they had 317 million theme park attendance in 2000, and then it grew to 324 million in 2002. So if we take a look at what the rate of change would be, I need to set that up as a fraction. So I'm looking at my change in y, 324 minus 317, over my change in x, 2002 minus 2000. So this becomes 7, and then 2002 minus 2000 is 2. Then when I go 7 divided by 2, I end up with an answer of 3.5. Now I'm going to bring back that table. I want you to think about what does 3.5 mean in this particular problem? So if you're looking at this table, and we talk about that the rate of change is 3.5, what 3.5 represents is the number in millions of the rate of change in millions of attendance over those each year between these 2 years. So in other words, it grew 3.5 million people per year. So 3.5 million people more went in 2001 than in 2000, and then in 2002 than in 2001. Okay, so it's growing by a rate of 3.5 million per year. And then the last problem that I want to work on today, remember we're breaking 3.3 into 2 sections, is looking at 2 tables and deciding if they are linear. Keep in mind that linear means that they create a straight line. So if these 2 are linear, what it means is that the rate of change will be constant. So if you look at this, from -6 to -2, this is going down by 2. Down by 2, down by 2. This one is going up by 3, up by 3, up by 3. So my rate is -2 over 3. Right? My change in y over my change in x. Be careful, it's always y first, which is difficult because the y is listed second. So my rate of change here is -2 over 3. -2/3 would be my rate of change. And in this particular problem, we don't know what that represents because we don't know what x and what y are. We just know they're variables. Now I want you to be careful on a problem like this one. So this one is linear, sorry. If it has a constant rate of change like that, it means it is linear. It will create a straight line. So over here, this is going up by 2. Then this one is up by 4. Up by 2. Up by 4. Over here, this goes up by 2. Up by 2. Up by 2. And then this one is going up by 1. Now, if you think about over here, you could probably guess what the next number is going to be. Right? I mean, you may see a pattern here, 2, 4, 2, 4. You may know kind of what's coming next. However, it's not asking if there's a pattern. It's asking if there's a constant rate of change. And so the rate of change between these 2 would be 2 over 2, which would be 1. But between here, it would be 4 over 2, which is 2. Over here, it would be 2 over 2, which is 1. And then here it would be 4 over 1, which is 4. So there is no constant rate of change. It's definitely changing, just not at a constant rate. So this is not a linear function. Right? It will not create a straight line. It's kind of all over the place. And so that's what you're looking at with these tables. Do they create a straight line? And that's all we're going to work on from the first half of Chapter 3.3. Thank you for watching the video. Please do not forget to answer the questions on the bottom of this page. I'll see you in class.